In this video, I'm going to show you how to use the T.test function to perform a two-sided test about a single population mean. To start, you need to have a set of hypotheses, and we'll see our null hypothesis here is that the mean of our population is equal to 1 versus an alternative that the mean of our population is not equal to 1. We'll use the R not equals notation here. We'd also need to decide upon a significance level or a probability of a type 1 error for our test, and so we'll decide upon using 0.03 here. And then we need to have a rule for rejecting our null hypothesis, and that rule here will be sort of the standard rule that uses these p-values, where we're going to say we're going to reject our null hypothesis if the p-value we have is smaller than the significance level we're using there. Now what we need to do is go out and actually collect a simple random sample from our population, or an independent sample there. I didn't actually do this here, I just made up these numbers, but we'll pretend they are a simple random sample sitting inside here. And then we need to check these to make sure that these are indeed following either a normal distribution or they're not super skewed or there's not really any outliers in them. The way I can do that is I can load these up and then I can plot some graphs. And indeed, if I look at these graphs here, we'll notice that they look kind of normal here. Doesn't look perfectly normal, but it's a small sample size. And then if I look over here, this doesn't telling me I don't really have any outliers, and nothing looks super skewed on this. So this should be fine to run this test here. Now, if I want to run this test, I can use this T.test option. And what I'd have to tell it is what my data values are. So I'll set up X here, which will be my samp. That's that vector right there. Then I need to come along and I need to tell it the alternative. And the alternative here is a not equals alternative, so that's a two-sided alternative. So I'll just say two-sided. And then the last thing I need to tell it is what my hypothesized mean value is. Well, that's the number we used in our null hypothesis here, and that's actually 1. So we just type in 1 there. And then there's some other options for other types of tests. We're going to leave them out because they don't apply to this. And I can go ahead and just run this. And if I look down here, what I'll see is I have a one sample t-test. I do indeed have one sample. It'll give me my p-value. It'll tell me some degrees of freedom that got used there. And it'll tell me a test statistic. And then it will also tell me right here that my alternative was what my alternative actually said. The true mean was not equal to 1. So I know I got the right test run here. And now if I want to make a decision based upon this, I'll just use my p-value criteria for right now. I'm going to look at this and say, well, my p-value is 0.04857, and that happens to be bigger than the 0.03. So based upon this, I'm going to decide that I'm going to fail to reject this null hypothesis. If indeed this was true data, I'd sort of say I don't have any reason to question the null hypothesis there. It's not real data, so we won't worry about it too much at the moment. And so that's how you can use the T.test to perform these calculations there. But you do need to make sure you check those assumptions first. Okay.